What happens when humanity dares to send a probe to the Sun? The Parker Solar Probe, the fastest spacecraft ever built, is on an audacious mission to unveil cosmic secrets that could transform our understanding of the solar system. In this video, we'll explore its groundbreaking discoveries and how they're revolutionizing our view of the Sun. Make sure to stick to the end for crazy facts and discoveries. In 2018, NASA launched the Parker Solar Probe, and it has made an extraordinary journey by touching the outer layer of the Sun and flying closer to the Sun than any other spacecraft, just within 6 million kilometers. To put that into perspective, that's about 7 times closer than Mercury, the planet closest to the Sun. Upon its first swing by of the Sun, the probe made a historic breakthrough: the discovery of a mysterious and unexpected magnetic field structure within the solar wind, offering fresh, unprecedented insights into how this solar wind forms and behaves as it travels toward Earth. Imagine a spacecraft surviving temperatures of 1,400 degrees Celsius, flying so close to the Sun that it risks imminent disintegration. How does it survive? And what cosmic revelations does it uncover along the way? Let's find out. The Parker Solar Probe's mission is bold, audacious, and full of determination. No spacecraft has ever ventured this close to the Sun before, traveling at blistering speeds exceeding 700,000 kilometers per hour. It's faster than any object humanity has ever constructed. But it's not just about speed. It's about breaking barriers in our understanding of solar phenomena. As the probe nears the Sun, it collects data that could alter everything we know about solar winds, magnetic fields, and more. But how does it survive such unrelenting heat and radiation? The Sun's outer atmosphere, the corona, is infinitely hotter than its surface. So how does the Parker Solar Probe survive? The key is its innovative thermal protection system, TPS, made from carbon composite materials. This insulating shield keeps the spacecraft at a comfortable 30 degrees Celsius, despite the Sun's heat being over 45 times hotter. The TPS is engineered to endure extreme temperatures up to 1,370 degrees Celsius, allowing the probe to get incredibly close without melting away. The spacecraft also features sensitive sensors and protective coatings that shield its delicate instruments, enabling it to survive the harsh conditions and continue gathering vital data. But what secrets did the probe unveil about the Sun's corona? The Parker Solar Probe's data is revealing the truth behind the Sun's corona, which has perplexed scientists for years. The corona is vastly hotter than the Sun's surface. 400 times hotter. And the probe has found that it's powered by magnetic waves, not just solar radiation. These magnetic waves transfer energy to the corona, superheating it. This breakthrough helps explain why the corona stays hotter than the Sun's surface and could forever change our understanding of how solar energy flows. The Parker Solar Probe has captured high-resolution photographs of the Sun, revealing previously unseen features like intricate coronal loops and complex magnetic field structures we have never seen before. These images offer new insights into how the Sun's magnetic fields heat the corona and influence solar phenomena. Parker has also found solar winds blowing crazy fast speeds. A solar wind is the constant stream of charged particles from the Sun, and it affects Earth in many ways, from stunning auroras to disrupting satellites and power grids. The Parker Solar Probe has discovered more about how solar wind forms and evolves. It revealed that solar wind accelerates faster than expected, reaching speeds of up to 700 kilometers per hour. The probe's data on particle density, speed, and magnetic properties will help scientists predict solar storms and protect technology like satellites and power grids. A better understanding of solar wind is critical for improving space weather forecasts and shielding Earth's infrastructure from dangerous solar storms. Solar storms, including solar flares and coronal mass ejections, can wreak havoc on satellites and disrupt power grids. The Parker Solar Probe is helping scientists understand these storms more deeply. By diving into the Sun's corona, it's studying the conditions that cause solar flares and coronal mass ejections. The probe is observing how faster flows of charged particles can trigger solar storms and the magnetic fields that drive these explosive eruptions. This data helps improve solar storm predictions, allowing us to mitigate the impact on Earth's technology. The probe is also providing new, groundbreaking insights into how solar storms interact with Earth's magnetic field. The Parker Solar Probe teaches us many things about the Sun's magnetic field. The Sun's magnetic field, which governs phenomena like solar wind, sunspots, and flares, was previously thought to be relatively steady, but the probe has revealed its highly dynamic and turbulent nature. For example, the probe detected switchbacks, sudden reversals in the magnetic field's direction, occurring closer to the Sun than ever measured, at distances as close as 13 million kilometers. These switchbacks are believed to play a critical role in accelerating solar wind particles and heating the corona, two processes that have puzzled scientists for decades. The data also showed that magnetic fields near the Sun can oscillate at speeds exceeding 100 kilometers per second, further highlighting the complexity of solar activity. This new understanding is reshaping theories on how the Sun transfers energy to its outer layers and into the solar system. Qualitatively, the probe has painted a picture of a far more chaotic and active Sun than previously imagined, showing that its magnetic fields are not static but alive with unpredictable fluctuations. By directly measuring these fields in the Sun's outer atmosphere, the Parker Solar Probe is providing an unprecedented look into their structure and behavior, helping scientists unlock secrets about phenomena like solar flares, coronal mass ejections, and their far-reaching effects on space weather. Each pass of the probe reveals new data, solidifying its role in transforming our knowledge of the Sun. Don't forget to subscribe to our channel and check out our other videos. What do you think will be the next big discovery? Let us know in the comments below. But the Sun still has many secrets to reveal, and the Parker Solar Probe is just getting started. Stay tuned for the next chapter in humanity's exploration of the cosmos.